triangles. Alright, so you have this piece of paper. It is called Reteach, even though we haven't learned it yet, but obviously I'm going to teach you from it. First of all, we're going to talk about a geometric mean. You've heard about a mean before, just not a geometric mean. What is a mean? Average. How do you find the mean of three numbers? You add all three of them together and you divide by 3, right? The dividing by 3 kind of undoes the having 3 pieces. The geometric mean is kind of the same. You're taking two numbers, you're going to multiply it together and take the square root. Because there's two numbers, you're taking the square root. Later, if you go to higher up math, you'll see sometimes where people talk about how the geometric mean is more appropriate than the arithmetic mean, which is the one you're used to, adding them together and dividing by 3. But you will probably never see it other than in geometry right now. So we're going to find the geometric mean. And the formula is given up here, and that's what we're going to use our highlighters for. So, the formula for geometric mean is we take one of the values over what we are looking for, the geometric mean, and that should be or is proportional to the geometric mean over the other value that we are given. This also relates to right triangles, and I'll show you how in a minute. So there is the formula we're going to use for numbers 1, 2, and 3. We also are going to get our values either in exact squares or we are going to divide them out into simplified radicals. It's been a little while since we've done that, so this will be a review of that as well. So, you'll see what I'm talking about in case you forgot. So in number 1, which value do you want to make A? In number 1. Doesn't matter which one though. Okay, and C then is 25, and we're looking for B. So we're going to set up our proportion as 4 over B equals B over 25. We've done this over and over and over again. How do we solve one of these? Cross multiply. What's B times 25? Yes, where did I get B? 4 times 25. 100. And what's B times B? How do I solve an equation that's B squared equals something? Okay, and I'm going to put it up here because I'm kind of out of room. Take the square root. What's the square root of 10? Why did I just tell you the answer? What's the square root of 100? Good. Now, when you did this in algebra, you also wrote what? Do you remember? Positive and negative 10. Now, we are not going to do that because we're talking about side lengths of a triangle in a minute. And can pieces of a triangle have negative values? You need to know that when you're solving these, you need to have the positive and negative answer. But since we're going to be talking about triangles, we can't have a negative value. Okay? Alright, how do you set up number 2? 9 over B equals B over 100. Then what? Cross multiply. B squared equals 900. Let's see if I can ask the question and not give you the answer. What is the square root of 900? Number 3. Yep. Yes. 8. The reason I'm making you set it up, though, is because in a minute, it won't always be this way. 8 over B equals B over 12. What is 8 times 12? 96 equals b squared. And I'm going to rewrite it up here because guess what? What's the square root of b of 96? 9.7 whatever. Don't write that down. We're not doing 9 point anything. It has been a while since we have done this. We did it when we started the beginning of the year. But we are going to, when we take the square root, I need the answer in a perfect square or a simplified radical. And I did teach you how to do that at the beginning of the year, but in case you have forgotten, we're going to talk about it. In order to get it in a simplified radical, we will need the perfect squares. So write these to the side. What I mean by the perfect squares is like, what is 1 squared? What is 2 squared? 3 squared? 4 squared? 5 squared? $64, 81, 100, 121. We're going to go to 15. 144. So there's 12. 13 squared. 14 squared. And 15 is 225. We're going to stop there. The reason we're actually getting these in perfect squares is in a minute, when we are actually using these in a triangle, we sometimes will have to use this number to find other values. If you round it, you're going to get the wrong answer. You need to leave it as a perfect square. Now, does anybody remember what we did once we got a number and we had perfect squares? See what divides into it. We want the largest perfect square that divides into 96. I would start at about half. What's about half of 96? Okay. 36. What's 90? Does 96 divided by 36 give you an even number? Not an even number, sorry, a whole number? You should be dividing 96 divided by 36. It's not a whole number? Okay, then move on to 25. I think that's also a no. How about 16? 16 times what? Do you guys remember doing that part? Even though it's been a while? Okay. Then we write B equals what's the square root of 16? What about square root of 6? You can't, it's some decimal, so we're just going to leave it alone. This is my answer. I take the square root of the perfect square, I leave the other one in the radical, which is what that square root is actually called. The reason I need the biggest perfect square is because I don't want anything extra left in there that would actually divide out. Alright, now we're going to talk about how this has to do with triangles. So later though today, when we'll have a lot of missing pieces in this triangle, like we might have to find this piece and this piece and that piece. Well, if we have to use this value to find all those, which we will, then we don't need that to be some decimal or we're going to get everything wrong if you keep using a decimal over and over again. That's why bridges collapse, okay? Okay. Number 4. Before we do number 4, let's talk about this figure here. Okay, so I told you guys that we are going to use the same formula as that we just used, but we're going to use it for a triangle. I'm using the exact same colors, and you're going to want to do the same for what I just had. In my formula, I'm going to match it. The first value, like I had, was up there, goes along with part of the hypotenuse of that triangle. So this 9 came from the hypotenuse, part of the hypotenuse of the triangle. this value right here, x, is the altitude of the triangle. And 4 is the other portion of the hypotenuse. Something I need you to realize is that the altitude of the triangle always goes at the bottom and then on the top. Some people get confused and put x here every single time. It's not that x goes there every single time. It's that the altitude goes there every single time. It's the location, not the fact that it's the variable. You'll see what I mean when we work some of these out. So we're going to look, I'm going to highlight this picture the same. So I've got part of the hypotenuse, the altitude, and the other part of the hypotenuse. Alright, number 4 says that EH is 6, GH is 3, and it wants us to find FH. Now this one looks just like this one, so I don't have to do anything that doesn't look the same. I'm going to write number 4 here, so I've got my work here, because we're going to have to erase and use the same problem. How are we going to set this up then? 6 over x over 3, okay? Then cross multiply, x squared equals 18. Is 18 a perfect square? No, so I'm going to have to find a factor of 18 that is a perfect square. 9 times what? What is the square root of 9? So my answer to number 4 is 3 square root of 2. Okay, I'm going to erase the picture and relabel for number 5. So this time EH is 12. Evidently going to have to change the ink on all my pens. 12. FH is 6. HG is what we are looking for. So I'm going to label it X this time. This is what I mean when I say people automatically are like, oh, X goes here, here always. That's not true. How are we going to set up this proportion? Over 6 equals 6 over x. I like to remember it too, and you will probably like, what? I like to remember it as outside over in equals in over out. Out, in, out. Okay, I like these better because I don't have to do the perfect square simplification because I don't have a square root in a minute. So I'm going to cross multiply and get 12x equals, okay, then divide by 12, so x equals, so number 5 is 3. I'm going to erase again. I want you guys to try number 6. Alright, number 6. We have to label it again. So I've got FG is 19, but that's the entire piece. This whole thing is 19. Hope you noticed that when you were working it. FH is 15. No, I can't read. EH is 15. We want to know what FH is. We need HG first. 4, because you subtract. Okay. Alright, then what did you set up for your proportion? Okay. 15 over x equals x over 4. Cross multiply, and you get x squared equals 60. Is 60 a perfect square? No, so we're going to have to simplify the radical. Yeah, I got to get all new ink in all these pens. What perfect square divides into 60? What's a factor that's 4? Did you feel like that was too small? 4 and 15, okay. What's the square root of 4? So what's left inside? 15. So 2 square root of 15. Okay, we're going to do some more examples with that, but we're not doing anything new now. I need you to either cut this so that it will fit in your notebook, or you can fold it in half, but it goes on 106. Once you have done that, tear out page 667. Once you've done that, tear out that page. Okay. By the Pythagorean theorem, yeah. That's what I mean by it's not too bad. Alright, the first thing we're going to do, though, just to keep consistent, we are going to highlight what we highlighted earlier at the exact same color. It's just, this is oriented differently. So highlight one of the links to the hypotenuse in your first color. Highlight the altitude in whatever color you highlighted the altitude. And the other length of the hypotenuse in the other color. How do I know that's the hypotenuse? It's opposite the right angle of the triangle, of the big triangle. How many triangles are actually here? 3. You got this one, and this one. And guess what? They're all right triangles, which helps us in a minute. Okay. We're going to find x first. That is no different than what we just did. How do we set up for the proportion to find x? 10 over x equals x over 2. Cross multiplying gives us x squared equals 20. Then what do? Okay, we take the square root, and we'll have to pull out a perfect square because it is not, 20 is not a perfect square. What perfect square is a factor of 20? 4 times what? So x is equal to 2 root 5, yep. That's part of the problem. I still have to find y and z. I like to replace this up here with 2 square root of 5. It'll make sense why I needed that in a minute. But I'm going to find y next. Not because I have to find y next, but because I just like it to be in alphabetical order. How do you think I'm going to find y? Equals. So what are you using? That's the Pythagorean theorem. How come it equals y squared and not something else? Y is the hypotenuse, so that's what it's C, A, B, C. Something you've probably not done before is this part right here. What is 10 squared? What is 2 square root of 5 squared? I will help you. It's the same as 2 squared times the square root of 5 squared. It is 20 is the answer. You also, instead of doing this was the same as the square root of 20, and any square root squared is the number. I forgot my squared right here. Your calculator also understands this if you needed to type it in. But it's the same as 2 times 2, which is 4, times the square root of 5 squared is 5. So it's 4 times 5 is 20. Alright, so that is 120 equals y squared. So how do I keep solving that? Pull out a perfect square. Doesn't have one. 4 times what is 120? 30. So what is y equal to? There's y. How do you find z? Okay, now we're using this triangle. 2 squared plus 2 square root of 5 squared equals z squared. What is 2 squared? What is 2 square root of 5 squared? Four plus 20. What perfect square goes into 24? 4 times. So what is z equal to? I've then found every missing piece, x, y, and z. So you always will find the altitude first, or if you're missing one of these, you can do that first, using the geometric mean, and then you're going to use the Pythagorean theorem to find the other missing pieces. I want you guys to work on number 10 and find x, y, and z. I'm going to leave my work there because you still need to see it. But number 10, find x, y, and z. What's in the other piece? Alright, so 5 over x equals x over 7, and you cross multiply and get x squared equals, okay. Then you're going to take the square root. Is 35 a perfect square? What does it break into? 1 and 35. If 1 is the only thing that will go into it, you leave it as x equals square root of 35. So just leave that alone. Which helps you when you have to square it in a minute. You don't have to worry about squaring anything extra. Alright, if this is square root of 35, how do I find y? What is 5 squared? What is square root of 35 squared? See, that helps you on that one a lot. And that equals y squared. What is 25 plus 35? And you already broke that up a second ago. Right on the other page, not right there. It's what to? 4 and 15, which ends up being what? 2 square root of 15. Since we already did it, you don't have to have this step at all. You could just jump straight to 2 square root of 15. Because we did it on the other page. Alright, how about z? What'd you set up? And 7 squared? And we already know that the square root of 35 squared is 35. What is 49 plus 35? So take the square root. 24, and 21, does it not seem that they all break into 4? There are your 3 answers. We didn't do very many because there's a lot of work for the few we did. So your homework is in your book. Page 671. Four through 7. 11 through 18.